Radiotherapy's UK Cambridge Centre podcast. In this Integrated Cancer Medicine Research in Focus series, I talk to various ICM members about their research and how it is supported by the vision of the Mark Foundation Institute for Integrated Cancer Medicine. MFICM research uses cutting-edge analytics to maximise the use of diverse high-volume datasets and by capturing cancer heterogeneity in time and space in patients receiving active treatment. Integrated cancer medicine aims to transform the way the world treats cancer by affecting patients along their treatment pathway and ultimately accelerate cures.
So today I have with me Raj Jena, and he's going to talk about his research and specifically the InnerEye Project. Dr. Raj Jena is a clinical consultant and radiation oncologist at Cambridge University Hospitals and a member of the CRUK Cambridge Centre at the University of Cambridge. To start with, Raj, could you please outline your research focus?
Yes, of course. So I have a very nice job. I do 50% clinical work and 50% research work, and the two kind of come together. My research focus is mainly on analysis of images, mainly because we use a lot of image data in radiotherapy planning and also trying to sort of model the effects of outcomes of radiotherapy treatment. And then on the clinical side, I use both radiotherapy and drug treatments for patients who've got tumours of the brain and spine in the main. So it's very nice because I get to see both the sort of development and the application of image-based tools that I build with my team.
What does an average day or an average week look like for you? Where are you in the week? How do you spend your time?
I spend about half the time in the hospital with sort of patient-focused care. My research team is based in the Maxwell Centre, which is over in the West Cambridge site. And it's a lovely place to be, A, because it's sort of away from the hospital and it has a very nice sort of ambience to it. It's the university's collaboration and technology transfer building, if you like. So in the building, we have interesting people from Dyson, the National Physical Laboratory, and then just around the corner, obviously, we've got the computer science department, physics proper, and then just a little bit further away is the mathematics department. So it's very nice because we can go and speak to people about ideas for building new machine learning models and meet them face to face.
That's really exciting. So it's a kind of a multidisciplinary hub of learning. It's fantastic.
It is, yeah.
Brilliant. And can you tell me about the InnerEye Project? How long has it been going on? And what were your original aims with it?
So the InnerEye Project is actually Microsoft Research's original project, and that started in 2012. I met a chap called Antonio Cremonesi, who was the founder of InnerEye back then, because he came to give a talk. He's very interested in computer vision, even before the current focus on AI, and he came to give a talk about how he was using tools and algorithms that have been built in order to allow you to play video games using your body. So, for example, if you wanted to play like a sports game, instead of picking up a controller, you could play by moving your hands, to simulate tennis or a golf swing. And he'd basically built computer vision techniques that were able to parse out the sort of position of the body, the external anatomy of the body, if you like, from two cameras that were facing, looking at you. And he was very interested in how we might be able to use that to look at information for regions of the body on CT scans and MRI scans in particular. So he came to the hospital and talked to us about it. I said to him, you need to come to radiotherapy because we do this all the time. And we walked into a room where there were about 20 people who, in order to plan radiotherapy for patients of ours, were having to draw around both tumour targets and healthy anatomy. And that's when we decided effectively to work together on that project. That's what then became Project InnerEye effectively.
So it's a little bit like auto-segmentation that we do in the integrated cancer medicine, whereby an algorithm would segment all of the metastases of a cancer, and then that would save a radiographer so much time because they wouldn't have had to do that themselves manually. Is that similar? Yeah,
that's exactly right. But we've been doing this for a long time. When we first started, we used very simple early machine learning algorithms that started to see really quite impressive performance. But it was really only in about 2015, 2016, when some of the seminal papers on deep learning came out, that we then thought, okay, well, let's see if we can use the power of some of the deep learning algorithms on this. And then we suddenly started to see a significant improvement in how well these algorithms performed. And it was on that point that within Microsoft, people decided that we should take this project a bit more seriously because they could see the applications. And it also strengthened our collaboration, here with the hospital and the university.
What kind of cancers can this method treat? Is it all types of cancer, or have you focused on specific ones?
So we've looked at different tumor types using underlying InnerEye technology, but we've only advanced 2 to the sort of level of being a medical device. And we chose those very carefully. So we chose prostate cancer. And the reason for that is that it's a very common indication for radiation therapy in our department. So even though it doesn't take too long to actually do this segmentation, we have a lot of patients coming through, maybe up to about 25-30% of our workload can be patients with prostate cancer. And then going to the other end of the body, we chose head and neck cancer, which strangely, for those of that don't know, is sort of the head and neck region, but not including tumours of the brain. So it's tumours that sort of occur around the back of the mouth in particular, where radiotherapy is a very important treatment for those tumours. And the reason we chose that is that it takes a long time to mark out all of the anatomical structures. There are lots of nerves and swallowing structures and things that you need to worry about when you're planning radiation treatment for a head and neck cancer. So it can take up to nearly 2 hours for a consultant to do that. So we chose one that was high intensity for the clinician and one that was high volume for the clinician. And that's basically what's gone into our first offering.
But it could be cancer agnostic, presumably, this technique. Yeah.
That's right. Yes. In the research setting, we're sort of joining up the dots. We've built one that's looking in particular at anything in the thorax effectively, but we're mainly focusing on breast cancer and certain lung cancers effectively for that one. And then I think the next one that we really want to do, which we've got a very interesting partnership potentially with a Vietnamese group, is to look at liver. So liver tumours in particular, that would be useful. The interesting thing about our work on InnerEye was being able to do the final mile development. In other words, to take something from being a research tool and actually turn it into a medical device. So most of us as researchers are familiar with building quite cutting edge tools of various sorts, but obviously they're built in order to answer a research question in the main. And so the kind of logical endpoint is to complete your analysis and to write it up. So it might end up as a sort of paper, and it may be that you share the code as part of the paper kind of thing. But it isn't easy to take research code and then develop into a medical device. And we started doing that. Basically, the idea for that came just before the pandemic because Microsoft decided that they would release all of the code for InnerEye publicly as open source. They felt that was the best way to make it impactful once we'd tested it in the hospital and made sure that it was useful. And so we took that on basically, and we got some money from the NHS AI lab to basically work on all of the necessary evaluations and tests and things to turn this into an actual medical device piece of software. And at that point, in order to make things very clear, we sort of changed the name from InnerEye to Asiris. So you may hear both names sort of in discussion. Asiris is effectively the medical device, InnerEye is the underlying technology. And so that's been really interesting, working with lots of groups in the hospital who have the understanding of how to build something. But often the hospital is very good at building a physical thing. So our main experience of medical devices in the hospital is with building sort of prostheses or things that you might put onto or on the surface of a patient's body in order to help them walk or function, for example. But this is the first time that the hospital had actually built an AI medical device. So it was an interesting learning curve for us all.
One of my next questions would be, has it been used in the clinic yet? So obviously it has. So what impact do you think it's having on patient treatment outcomes?
Yeah, I mean, so we turned it on as research code in 2018. And basically, I know it's useful because my consultant colleagues complain when it goes down. Like, when can we have the AI back? That's a good sign. And it would probably sort of about 100 to 120 patients sort of each month benefit from starting radiotherapy more quickly with InnerEye. And what it means is that for some of the fastest growing tumours, there's a national target that says once you sit with a patient and decide to press the go button on curative radiotherapy, you have to get them on treatment within 31 days. But for some of the fastest growing head and neck cancers, where every day really makes a difference, we're able to bring that down to sort of like a 2-week turnaround using a range of technologies, but one of them is obviously as Iris itself, sort of thing. So it is impactful. And we know that, from a time-saving point of view, we spend about £6,000 a year on the cloud computing cost to run as Iris, and that saves about £120,000 of consultants' time. So it makes sense even just from a financial point of view. It's a cost-effective tool.
You're personalising their treatment and getting them in so much quicker so that, hopefully the treatment works better.
Exactly, yeah.
That's really wonderful to hear. So how does it fit in with the ICM vision? I mean, obviously I'm from the Integrated Cancer Medicine programme, so it's nice to make the link. How do you see it fitting in with our vision?
I think there are two things. I mean, the first thing, and, I've spoken extensively with Sarah Burge about this, is this idea of sort of shared tooling so that we don't reinvent the wheel, and that basically the entire sort of InnerEye tooling stack, and in particular all the know-how that we have around using it for over 10 years, then becomes available within ICM. So if there's a requirement to sort of be able to segment things and say, okay, well, how am I going to do that? Instead of sort of reinventing the wheel, then obviously that tool stack becomes available. We've also built other tools to help you build the data that you need in order to build these AI models, because actually, doing this now, the hardest bit is actually pulling all of the data together to train machine learning models. So we've got tools, again, which we're able to share with other researchers in order to do that. And then the second part is more the understanding that when you build things, particularly when you build things that are software, that you build them in a way that will allow them to be democratized. So in other words, right from the beginning, from when you first start, instead of just thinking, I'm just going to write this scratchy code and it just needs to turn this genomic file into this column of data sort of thing, you write it in a way that means it's reusable, it's integratable, and potentially, could be used so that we can turn that into a medical device. So Sarah's very keen that things that get built out in ICM would be shareable with other hospitals. And the fact is that easiest way, it's fine if you've got a big research active hospital that's got lots of people that can take on research code and support it to be evaluated against patients. But for many small hospitals, if they wanted to start using, for example, ICM's genomic pipelines for their own patients, they just haven't got the ability to do that. So until you turn it into a medical device, they simply wouldn't even be allowed to have it in their hospital. So these things really matter.
Yeah, making it open source, I think, is just such a wonderful thing, because it just means that so many people can tap into it and tap into that fantastic knowledge that you've created, that wonderful thing that you've created. In a space in Cambridge, we're so lucky. We have the ability to create these brilliant things. And so it's wonderful to share it with the world.
Indeed. Yeah. I mean, I think, a lot of people might think immediately that they kind of want to put your hands tightly around your code if it contains innovation, and that open source is a barrier to that. But I think, again, that was one of the reasons I was keen to do the project, is as IRIS stands for Open Source AI Radiotherapy Image Segmentation. So, and we managed to do that and build it out as open source. So you can keep your intellectual property and know-how and yet still open source your code. So it is possible to do both. And I think also what's very nice is we have, strong support from Cambridge Enterprise in order to kind of actually be able to do this and understand, how do you move forwards, identify potential people to work with that you want to license your code and things. And having that expertise on site is tremendous. We're, Sarah and I, very keen to allow PhD students to understand right from the beginning of their PhD that they can do this, that this support is available. So particularly as a hallmark of what we can offer in ICM and in Cambridge.
It's just fantastic, isn't it? Cambridge is so well resourced and the university is so well supported. We are extremely lucky here. Yeah. Obviously, you've mentioned that it was a collaboration with Microsoft, and you've also mentioned the hospital and data. Can you tell me what opportunities and challenges that doing these kind of big collaborations with A, the hospital, and B, an outside organisation presents you?
I mean, I think the biggest issue really relates around governance. I'm very picky about companies that I work with. But one of the things I liked about Microsoft was that they have an understanding of trying to promote things for societal good, that you work on something because you can see a benefit. But they are also very risk averse. So, you hear stories about data sharing with commercial entities, that have gone wrong, but Microsoft actually are very, very good. They follow a process that's very similar to our own information governance process in the hospital. So I think that is a good thing. It does mean, though, however, that sometimes it takes a lot longer to share data with a commercial partner than you would think. But I think it's then very helpful to think about what do you actually need to share. And I think increasingly now with things like cloud computing, what we actually discover is you may not need to share data. It may be possible to have the data sit in your lab or your hospital and have the code come into your hospital and then return what's needed rather than actually sharing that very sensitive data. And so this principle of data federation, if you like, which has now gone from being an idea to kind of, having established ways of doing it. So I think those have been the key things, really. And I think it's one of the reasons why it's taken us 10 years to declare success on InnerEye from end to end. And undoubtedly, some of those things would go much faster now, having the benefit of hindsight. But some things, it's worth waiting and it's worth going through that process because you then know that everything is done in a way that will allow you to innovate in the way that you really want to.
It leads me on, interestingly, we'll go back to the opportunities in a sec because I want to hear how great it is to collaborate with all these people. But I wanted to ask you that I know a lot of patients, having spoken to them, have concerns about their data being used by AI. And so how could you reassure them? I mean, what you've just said obviously is very reassuring, but how could you reassure them, that you've overcome these challenges of training the AI algorithms using real world data, but keeping it safe?
I've done a couple of patient engagement events through the course of the InnerEye Project with the AI Lab, and that was A, real fun, and B, very interesting. And I think the insights probably to share with other researchers are just come down to only a few things. The first thing and most important thing is that the patients want to know who's in control. So at the moment, we are mainly building automation AIs and AIs that do the first pass of an analysis. Even in ICM, unless Sarah's cracked it already, of course, and hasn't told me, we haven't built an AI that will do an end-to-end decision support task using integrated cancer medicine approaches. So patients want to know about control. Who's got control of that algorithm in the stepwise process? And then when it does go end-to-end, how does that algorithm sit effectively as a partner in multidisciplinary decision-making? And as long as they have confidence in the human that exerts control of how the AI's output is being used, they find very reassuring. And they like the fact that in Cambridge, we have humans that are likely to interact, that have a good enough understanding of that AI to know when it's going to work well and when it's not going to work well. That's the first insight. They think that the hospital and the university are high trust environments for their data. They already trust us to look after their data, clinical data in the hospital, very advanced genomics data in research labs. And so what they consider is that, look, when I consented to this, I had this understanding that this data is being used in this way, but the researchers and medical staff will keep it safe. And that's very, very important that we don't ever forget the trust that's placed by patients. And then the final thing is just sort of understanding the scope of the tool, because we often talk about things as being AI tools because we are using machine learning or deep learning or even data-driven approaches. But actually, when I explain to many patients what Iris does, they say, oh, okay, I really would rather you didn't call that AI, to be honest, because AI has visions of sort of robots and things, cameras watching me down the street and reading my number plate and things like this. This is not really I understand why you've called it AI, but this doesn't match the public's perception of AI, even if you're using it for research. And I think that's very important. So I think sometimes particularly when we do patient-facing elements, although we like to talk about using AI methods in integrated cancer medicine because it's kind of on trend at the moment, when we're patient-facing, we might do better to say that they're actually computerized tools or new statistical tools, because at the end of the day, much of what we're doing in AI is simply extending what we used to do with advanced statistics. So in particular, the line between advanced statistics and supervised machine learning is non-existent. They're the same thing. So I think those would be the three things I've learned really from talking to patients about working in this space.
Thanks for that, Raj. I think that will help those coming through think about it a little more, because we are interacting with patients so much more, rightly so, and we need to get the semantics right and make sure that they are feeling comfortable with what we're doing with their data.
Indeed. We also ran an event with the BRC with Miles Parks where patients for the first time got to actually hear researchers talking about the research they're doing with patient data. They found that tremendously reassuring. And there were in the comments and feedback saying, all I needed to do to allay my concerns for working on this study was to hear that researcher talking about what she or he was actually doing. And they found that immensely reassuring, whether it's a personal connection or whether it's actually them explaining this is exactly how your data is being used and bringing the story to life. I don't know, but I think that's something, again, encourage our early career researchers to do much more of, because it might seem frightening, but actually patients really, really enjoy hearing, our younger researchers talk about their work.
I'm organising, as you know, because you're going to come and speak this big ICM symposium in July, which is exactly, we've got the patients will be running through that conference as a golden thread, and they'll be involved in all the sessions, and we'll be presenting, and I'm going to ask all researchers to do a lay summary of their research to start with, so that everybody, for my own benefit as well, so that we're all very well informed and we understand, the research. So I'm really excited about that 2-day conference, so that we can take that further and encourage all our early career researchers to do similar things. So yeah, brilliant. Can we backpedal a little bit and tell me about the opportunities and the benefits that came from collaborating with Microsoft Cambridge and the hospital in this project?
Yeah, it's fantastic to work because Microsoft Research effectively operates a bit like a higher education institution. So, if you compare with our oncology department, there were group leaders and there were postdocs and similar things in terms of research papers, and patents were the currency, if you like, in that little part of research, which represents about 10% of Microsoft's workforce. The thing that was exciting for me was to embed myself in a group of people who represented the absolute bleeding edge of thinking in machine learning. And for example, to have a discussion about a paper that had come out 3 weeks ago in a conference kind of thing. And often we'd be picking up stuff from archive preprint and things like that. And it's a very open sharing community in terms of the people that build the underlying machine learning algorithms. So they share their ideas, share their thinking. And it was wonderful to start taking those and immediately start applying them to what we were doing. And that juice, if you like, of doing that and sort of being able to innovate and speak to really, really bright people who had amazing machine learning knowledge, but were hungry for the domain knowledge. How can this be used in the hospital? That was a really, really wonderful thing. And in a sense, we have the same with the centre in the hospital too. We've got some of the brightest minds from the university coming and engaging in research, and also hopefully some of them are curious to peek over the fence and kind of say, how does what I'm doing relate to what you do in the hospital? That was by far the best part of working with that collaboration.
Did you have to learn each other's language a little bit before you could have those conversations?
Yes. And again, I think it's the theory and practice thing, right? The best way to learn a language is by talking to someone with it. And I think because we were working on a project and because it was on cancer imaging, it meant that we did have to develop that shared language. We had to both agree, look, for this project to work, we've each got to meet in the middle and have a bit of understanding from each side kind of thing. And for example, one thing that I would usually do is when a new member joined the team, bring them to hospital and show them around so they could actually see and put these things to life, because otherwise you end up with these really bizarre misconceptions. Whereas if you actually see how things happen in a hospital, then you understand. A really simple example, I remember talking to one of the researchers when we were trying to build some segmentation models near the diaphragm, which of course moves up and down with breathing. I was trying to understand why sometimes the diaphragm looks so sort of wobbly on some scans, because obviously you're imaging something that's moving. Anyway, it transpired he thought that we just anaesthetized patients when we did scans. I thought that was hilarious. And I said, can you imagine? We do thousands of scans a day in just Addenbrooke's. And if we had to anaesthetize everybody, that would be backbreaking.
Patients. recovering.
But it was beautiful because in a way, you could just disavow somebody of sort of fundamental misunderstanding. And then clearly from that point onwards, and then I made sure that said chap then did come to the hospital and actually see how we prepare patients for radiotherapy. And then, of course, things like that don't happen. So, yeah.
Amazing. Obviously, you said that it's being used in the clinic. So has it become standard of care? And also, can you use it outside of Cambridge? You've talked a little bit about that already, but is it being used more widely?
So, yes. So for the AI award, we did all of the medical device checking in Cambridge and Birmingham, so that we had 2 centres doing the evaluation. We've also got it being used in UCLH and a set of American hospitals as well. So that's where it is at the moment. We are sort of in purdah at the moment because obviously we're doing the license transfer to then turn it into a commercial medical device. So at the moment, we're not sort of sharing it openly with other hospitals. But then obviously once it becomes a medical device, then it becomes much easier. And one of the things that we've done is to negotiate significant discounts so that if the NHS buys the product, they buy it at a much reduced price, basically, compared to if the company sells it elsewhere.
In places where there are fewer radiographers or even fewer hospitals, I'm thinking of places in the world where medical care is quite different. This could definitely help enormously in terms of saving time and saving money for countries that find that more difficult.
Indeed. The company we work, one of the reasons we partnered with them is that they've got a big base in sort of Southeast Asia, big group of hospitals in Singapore that they work with, very interested in deploying technology. And the other thing that no one realizes is in the US. So, of course, the US probably has about half of the radiotherapy machines in the world. It's a private healthcare system, so things are very different. But they are not like us. We have a big department with 8 radiotherapy machines, which, of course, can back each other up, and a huge kind of conglomeration of expertise, both clinical and research, to get the most out of those machines. What people don't realize is that there's large sections of the United States where there'll be one department with one radiotherapy machine. So, of course, they just, even in the US financial setting, they can't afford to deploy hundreds and hundreds of people for one radiotherapy machine. So again, AI is very, very useful there to help patients get onto treatment more quickly.
I have 2 more questions. My second to last one is, where do you see your research taking you in the next 5 to 10 years?
So I think that the sort of use of these tools for segmentation is effectively, we've been able to build medical grade tools. Then it's simply a case of sort of turning the handle and building more of these tools that help in more and more different applications. My group has moved on a little bit, and we're interested in sort of the combination of kind of generative AI and also sort of starting to work with Microsoft on the use of large language models, which I'm a bit skeptical about in general in terms of medical application. So we're using generative AI to synthesize images of cancer patients where we can't routinely get those images easily for one reason or another. So at the moment, Doris, my postdoc, we're working on an application where we can synthesize a connectomic map of the brain from a regular MRI scan. And that's amazing because it takes about 20 minutes to get a regular MRI scan for a brain tumor patient, over an hour to have the full connectomic scan, which most cancer patients can't do. And again, we cripple the hospital. So we built basically a generative AI model that can synthesize these well enough at the level that we can use it to understand connections around the tumor and how they might be affected by radiation therapy in order to individualize, take a more precision radiotherapy approach in the future. So that's one example of sort of, using generative AI, the kind of thing that's used for deep fake models and things like that. And the second is we're working with Microsoft on a large language model called Myra. So in general, large language models are trained on huge amounts of data on the internet. But what people don't realize is that about 0.1% of the data on the internet is of medical use. So therefore, a large language model is never going to have enough domain-specific knowledge to really start to be impactful, probably for the next 3 to 5 years. So Myra basically is one that's just designed to understand medical images. It's been fed every radiology textbook we could find and read those, and every radiology report that it could read. And basically what it does is to look at an image and try and predict what the radiologist would say about that image. And it's very cool level. Myra only works in 2D at the moment, which means it only works with X-rays, which for integrative cancer medicine is a bit boring. but give it time. And, we're kind of working actively with the team. And I'm very interested. Basically, I've got first dibs on Myra once it can look at a CT scan.
Brilliant. And then my last question would be, where do you see integrated cancer medicine taking us in the next 5 to 10 years?
I mean, it's going to be the future. I think it's just going to be really interesting to be at the beginning of that story as an innovator. Look, lots of people are in this space. Who will actually win in terms of sort of building workflows that actually start to be used in the clinic? It could be us. It may not be us. It could be done commercially before we get there. But one thing I know is that having done the ICM work, we'll generate new knowledge ourselves, but more important than that, we'll generate the understanding to really take apart any kind of integrative cancer workflow that's presented to us and really understand and say, how do we build this safely? Because I feel that when you've built one yourself, you're in a much, it's like a car, isn't it? They're black boxes to most of us. If you understand how a car works, you can start to have a go at understanding why it might not be working so well. And I think it's the same thing. But I think also, particularly with Sarah's work, is building maybe 2 new hospitals, the Children's Hospital and the Cancer Research Hospital, to be digitally native. So in other words, to actually build a hospital knowing that it's going to have an integrative cancer medicine algorithm as part of its staff. I think that's a really exciting idea. And again, I think the only centre in the world that has really done that successfully is the Mayo Clinic. They call it an AI factory there in the Mayo Clinic. But I think, again, they were retrofitting slightly. But I think for us, it'll be really interesting to see the two grow up together.
Thank you, Raj. It's been absolutely lovely to talk to you this morning. Thank you so much for telling me all about your research and for such an interesting conversation.
No problem. It's an absolute pleasure.
If you want to find out more about the work of the Mark Foundation Institute for Integrated Cancer Medicine, please visit our website at www.integratedcancermedicine.org, where you can find details of the ICM vision, all the current research, clinical trials, resources, publications, and team information. You can keep up to date with our latest news and events, and you can also sign up for our newsletter. If you would like more information about the work of the CRUK Cambridge Centre, please go to www.crukcambridgecentre.org.uk, or you can connect with us on Twitter using our handle @CRUKCamCentre. Thanks for listening, and do join us again soon.